Someone gave me a bunch of 555 timers as a gift yesterday, and I thought I have to find something to do with them useful, so I thought they might be able to drive this tall Tesla coil. And they can do it. We have 15 volts here going into this big 555 timer circuit into a MOSFET driver. Then there's another power supply controls the primary coil and the Tesla coil, about 9 turns, and there are 1,000 turns of secondary, and here's the MOSFET. So frequency comes in from the 555 timer through this little wire into the MOSFET driver, that little wire into the MOSFET, and that controls the flipping of this big circuit. So when we turn the power on here, we can see a light bulb begin to glow quite nicely, wirelessly, at about 25 watts going through the MOSFET, a little less than 2 amps, 15 volts. Other people may want to do this, so let's just tell everybody how we did it and how they can do it also. Now we're going to explain in some technical detail how to use a 555 timer to drive a single MOSFET Tesla coil. The first thing we have to do is put 15 volts DC, 12 volts isn't really enough, into two control circuits. This is the 555 timer circuit, all these wires and stuff. That's the timer itself, that little thing there. And this is a MOSFET driver, a standard driver. What happens is then this timer oscillates at several hundred kilohertz frequencies. An AC power pulse at about 0.15 volts come into the input of the MOSFET driver, and then this high voltage here will make it a bigger 5 or 6 volt flipping output, which goes into this gate of this MOSFET, and that's what makes this Tesla coil flip on or off. In summary, using a 555 timer to drive a single MOSFET Tesla coil, 15 volts DC into both the timer and the MOSFET driver, and that results in 0.15 volts AC from the 555 timer into the MOSFET driver, and then subsequently more voltage into the MOSFET, and that drives the whole circuit. Now there are already many circuits published in the literature which describe how to use a 555 timer to drive a MOSFET Tesla coil. And this is the most famous one here. A bit complicated, isn't it? And I tried to use it and I found errors. Nobody could really make it work using that circuit. So the first thing we have to realize is study the parts we use in the 555 timer. What we have to do here, we have two potentiometers. Here's your 555 timer. And we have resistors, which are okay. The two potentiometers, R2 and R4, need to be 0 to 500 ohm resistors. And here they are, R2 and R4. And they need to be about 500 ohms each, not 10,000 or something. It's very important. Other stuff's okay. The capacitor at 5 nanofarads okay. This thing over here. This other capacitor at 50 nanofarads okay. This thing here. The three things that control the frequency of this circuit are resistors R2 and R4, which are potentiometers, so they have to be right. And this capacitor here, which has some influence, C2. C3 is sort of like a control stability capacitor. So unless you get these three components right, 500 ohm, 500 ohm, 5 nanofarad, you aren't going to be able to do anything. So I've done that, and let's move forward. Now they also had these transistors here, which can be thrown away. We just put a MOSFET driver instead. And then we come over to our MOSFET over here, and there's a 10 nanofarad capacitor in parallel with the primary, and that's all we need. A standard driver MOSFET circuit has a 10 ohm resistor here and about a 10k ohm drain resistor there, but that's all very standard. And a little series resistor of a couple ohms there, which is also shown in the circuit, maybe 2 ohms. So technically now you're ready to go. We have all the parts. Now I've turned the power back on, so we have light coming out of a fluorescent bulb. We place it into the end of a wire which comes out of the top of the secondary coil, and also we get some light around the coil itself. But I've made it especially weak, not too strong. We only had 11 volts, 15 watts, 1.4 amps. And the reason is we're going to use the brightness of that light, which isn't that strong, to adjust the values of these R2 and R4 potentiometers for our timer. So let's just start with R2, and we'll twist it from 0 to 500 ohms and watch the light. So first we go up to 500 ohms, and you see the light turns off above about 400. Come back down again towards 0, and it manages to stay on at 0. We'll go off. There it went off. Now we'll come back up again, okay? Now we're going to look at R4 and twist it around. So at R4, twisting it around, first we're going to go up to 500 ohms. Turns off above a certain value. Now we're going to come back down through the peak, down to 0 again, and it turns off. So clearly there are median values required for this light to be on for both R2 and R4. And I've measured it. Adjust the potentiometers by maximizing light brightness. R2 should be about 160 ohms, 50 to 280. R4 should be about 290 ohms, 40 to 410. The optimal values are 160 and 190. And then the secondary coil under these gives you a resonance frequency under those conditions of about 639 kilohertz. It depends on voltage, but here we have a resonance frequency of about 660 kilohertz at 13 volts and 20 watts, 1.6 amps. So that's what the timer has to do, give you that frequency. And that, my friends, is how you use a 555 timer with a MOSFET driver to control a MOSFET and a tall Tesla coil at the right frequency. 15 volts coming in, then we put different amounts into the primary coil. The light comes on about 7 volts, here it is. We'll go a little higher now. 16 volts, 30 watts. And it's a very bright light coming up from some distance away from the coil. Of course, with more MOSFETs, you can make it more powerful. There's another way to do it which isn't as good. I'll show you now before we quit. Now there's another way to do it where you don't need a 555 timer. So put it over here. Instead you just take a wire from the bottom of the secondary coil and put that as input to the MOSFET driver. So you get a feedback cycle between the big coil up there and the MOSFET circuit. And it works quite well. We can turn it on at about 7 volts. Here we go. Just turned on at 7 volts, 8 volts. You get wireless power. Fairly powerful, but the trouble is this energy from the secondary wire is quite intense. It'll shock you if you touch it. It'll destroy the driver here. It'll also destroy the MOSFET. So it's not really as good except for just for play applications. Here we are at 11 volts. Very strong and pretty, but not really good for your MOSFET or for your driver. 11 volts. 4 amps, 12 volts coming into the driver. So we have several different ways we can do it. You can start with this simple method, and then you use a 555 timer if you want to get more sophisticated. I love wireless power. Love wireless power. See where it can shine. There's wireless power coming out. There it is. There it is. Comes right through the wire, look. Right through the insulation. All around the coil. Wireless power is just fantastic. Thank you very much.